Hi, I was doing some plant extraction, so I thought I would share my process. Here you can see the ground up plant in question. Normally a chemist would use setup like this. This is footage stolen from Nerd Rage. If you don't know him, go check him out. Anyway, the key feature here is the sock slot extractor. It is a device that you can load up with stuff and it will automatically cycle the fresh solvent through it. It is basically automatic self-siphoning device. If you, like me, don't have sock slot extractor or any glassware, basically, you can use method that I am using here. So this is just basic filter paper that I modified to allow vapor to pass through it. Of course, it has to be compatible with your solvent. On top of that you can place random container that you will fill with cold water. Ideally this should be glass container, but in the past I have used even polypropylene plastic cups. Also here is some kindergarten science, in case you wonder how you can make effectively holes in this filter paper. You can see that I intentionally offset the first hole from the bottom. This offset basically depends on how much material you have. Now let's put in just a little bit of a solvent. I'm using 50 ml of ethanol. Put your stuff that you want to extract into this filter paper. Do this outside your extraction container, because you can contaminate liquid. Then fill your cooling container with water. And be sure to keep outside dry. Now you can turn on your heat source and just wait. Actually, you should periodically check the temperature of your cooling water. One little problem this setup have is that the filter paper likes to suck in the solvent and carry stuff with it. This is not a big deal unless you work with extremely small quantities, in which case you shouldn't use this setup anyway. You should continue with extraction until you see that the solvent that comes out of the filter paper is basically clear. I guess depending on solvent and on what you are extracting. Here you can see plant material after extraction and you can see that it's quite off-colored. At this point I tested the extracted plant material and I can confirm that the chemical was not there. And here's the extract. It should be pale yellow oily resin material, but you can see that it has quite greenish tint to it. This is due to presence of chlorophyll. In this part I will try to extract the chlorophyll from the extract itself. Unfortunately, only way I can test for chlorophyll presence is by UV fluorescence. Which would not be so terrible, but unfortunately my only UV source is this PCB exposure unit I built some time ago. This is about 120 watt light source and the radiation from this thing is overwhelming. When you turn this thing on, basically whole world looks like it's dead. I will have to make some adjustments to the scene so you can see what I can see. Yeah, now we are cooking. There may be much better solutions to separate chlorophyll, but I know only about one solvent that can do this. And that is propane, or butane, or mixture of two. Now this will be a little bit crazy, but actually propane mixed with ethanol is not quite that volatile. But it's still pretty much flammable, so be aware of that, at least. I mean, you should be, unless you are 5 years old. Anyway, so you can see that there is quite clear separation of two fractions. Seems that chlorophyll content is not that different though. Also in the visible light, this is really nice. But the question is, how do we separate this? Seriously, what did you think? If you have one, you can use separatory funnel. Just never plug it up. Even though it should handle this pressure, there wouldn't be much higher than 1 atmosphere of pressure. I mean, do you see any problem here? I repeated this extraction about 6 or 8 times. Now on the left side you can see the butane fraction, and on the right side you can see the ethanol fraction. The ethanol one is quite muddy. It seems like it has some water content in it. To be fair, I also filtered butane fraction through some filter paper, so... But still it wasn't muddy, it seemed to be contaminated by some solid pieces. Now both fractions are dried and you can see quite clearly the color difference. Now let's look at this under UV light. So you can see this reddish fluorescence that is quite specific to chlorophyll. This is the butane fraction, even though you can see some orangey-green fluorescent blobs there. On the other hand, in the ethanol fraction you can see that the whole material is this orangey-green fluorescent thing. Although even here you can see some quite reddish spots that could indicate some presence of chlorophyll. So the separation is quite good, but not 100%.